Hello guys, today I am going to start on a topic of cervical cancer. Before going to this topic, I will show my model built application, how I built an application. Okay, this is model in which application is this cervical cancer detection using histopathology images or services. Cervical cancer detection using histopathological image, we can able to classify the cancer. So click here. Okay. Cervical cancer detection using histopathology images. Please upload the clear image. So you have to choose one file of image. So we can predict the which type of cervical cancer. See this type of this many types of photos I am having. So I am choosing this one. Okay, uploading. Then predicting the disease name inside the cervical cancer type of cervical cancer disease. Okay. Okay. We got an disease name. And see how I built the application inside this health checkup, home prediction, contact, name of the disease, negative for intrapathological malignancy, disease detail, and cause, normal cervical cells with no evidence of cancerous or cancerous changes, indicates healthy cervical epithelium. Treatment for this: routine cervical cancer screening as per guidelines. Maintain good reproductive and sexual health practices. See how I will the application for this model. So let's start the topic. Cervical cancer. According to the World Health Organization, cervical cancer is the fourth most frequent among women. Around 5,70,000 new cases were reported, and 3,11,000 people lost their lives because of disease in 2018. To reduce the risk of getting cervical cancer, it is crucial to know it in detail. This blog covers this information on the same. Who is most at risk of developing cervical cancer? Infection with a high risk strain of the human papillomavirus HPV is a known cause of cervical cancer. However, additional variables may have a role in developing cervical cancer, as not all HPV infected persons acquire cancer. Cancer risk factors for cervical cancer have been found, included a woman age, ethnicity, and family history, like smoking tobacco, HIV infection, suppression of the immune system, past or current chlamydia infection, overweight, using oral contraceptives for a long time, having three or more full-term pregnancies, having a full pregnancy before the age of 17, a family history of cervical cancer. What is the first cervical cancer system? Symptoms and indicators of cervical cancer in its first stage are seldom visible. In more advanced cervical cancer, there are several signs and symptoms, including after intercourse between cycles or menopause, a woman may have vaginal bleeding, a foul smelling red watery discharge from the vagina, pelvic or intercourse discomfort. Is cervical cancer usually fatal? When while it occurs less often now than it in the past, cervical cancer may still result in death in certain cases. In recent years, greater adoption of the PAP test has been the primary cause of fewer person dying from cervical cancer. What happens to your body when you have cervical cancer? Cervical cancer occurs when cells in a woman's cervix, the tube that links her uterus and vagina, became abnormal. See, this is a picture of image of the cells. Now, let's start on this. Okay, cervical cancer is one of the deadliest cancer affecting women, especially in developing nations. Despite the availability of screening methods like the pap smear test, early detection remains a challenge due to human errors and lack of automation. Machine learning offers a promising solution, enabling automatic, accurate, and fast detection of cancer. Before this, I will show I took two research paper: cervical cancer detection and classification using independent level sets and multi-SUVMs. See how this paper is segmentation cells and cryptoplasma of five types of cervical category they have shown, and this is a table of geometrical features of five different classes of segmented images from level sets. So I did one page, one research paper is this, and another research paper is this. Survey of cervical cancer prediction using machine learning, a comparative approaches. Okay, this research paper contains a table comparison the various surveyed approaches like this. Okay, by taking these two research papers, I'm going to tell you briefly some important points. Okay, various datasets were employed across different research sources. These include PAP smear images from the Nation Cancer Institute, dataset from UCI Respiratory, and clinical samples from hospitals like Cigna and Lampage Cancer Hospital. To enhance accuracy, preprocessing techniques were applied such as Gaussian filtering, Fuji C-means clustering, PCA for feature reduction, and independent level sets for segmentation. A wide range of machine learning models were used across studies. Support vector machines, random forest, K nearest neighbors, artificial neural network, that is ANN, and hybrid models were the most popular. The best result were obtained by combining random forest with k-means clustering, achieved an accuracy of 96.77%. I will show in the research paper. Okay, multi-class polymer SVM also showed excellent performance, reaching 95% accuracy in classifying cancer types using geometric and texture features. In contrast, basis ANN model showed lower accuracy, around 54%, indicating the new need for more advanced articultures. The models successfully classified pap smear images into different stages of cervical cancer, such as ASCUS, ASCH, LSIL, HSIL, and sequential cell carcinoma. These categories reflect the severity and progression of the diseases. support vector machine stood out as the most common used algorithm due to its robustness and high precision. When combined with effective preprocessing, it significantly improves classification performance. Also, image-based dataset and FTIR spectroscopy data are getting traction, pushing the boundaries of what's possible in automated cancer screening. Machine learning is revolutionizing cancer diagnostic, while where the still limitations like data imbalance and computational cost, the results are promising. With further research and real-time implementation, these models could play a role in saving lives through early detection and diagnosis. Okay, papers. In this paper, they showed a table comparison the various surveyed approaches. See the publisher, data set, number of features, software, pre-processing, and the other important methods, algorithms, accuracy, and classified as. Publisher, when who a data set from the respiratory of University of California at UCI, which was collected from hospital University de Casura in Russia. And number of features 38 and pre-processing and other important methods over sampling algorithm is SUM and accuracy they got about 90%. Like this, they have built the models. In this three types, support vector machine recursive features elimination SVM RFV around 90%. Another one support vector machine principal component analysis that is SVM PCA about 90%. Like this, they got the accuracies. And in another second one, second research paper, in this flowchart of methodology they did and calculation of this segmentation cell and cytoplasma of five types of cervical cytology. See, they have taken this and geometrical features of five different classes of segmented images from level sets. See, they have given everything. Type of diseases name ACS USA, ACEC, HS, LSIL, HSIL, like this. Geometrical features area of cells, area of nucleus, eccentricity of nucleus, ratio n bar c. Then they did calculation and then manual feature selection using the first two principal components and the by B, B plot functions. And they got confusion matrix like this target cell and another one also confusion matrix showing as accuracy of 85% for multi-classes quadratic SUM classifier and this one also confusion matrix showing an accuracy of 85% for multi-class Gaussian RBF SUM classifier. Okay, now coming to my model. In my model I shown you accuracy of 99.68 percentage. Let's talk about my model. Okay. So how I build a model. So I took model and I took a data set from this Mendelia LBC cervical cancer from the Kaggle. Then in this data set, they contain the images like different type of diseases which are come under the cervical cancer. See the disease classification. They are given in four: high sequential intraepithelial, low sequential intraepithelial, negative for intraepithelial, squamous cells, carcinoma. So come to our model that classes required. So I took that four classes and uploaded here. Then I did image segmentation. We did here data balance and pre-processing, preparation and modeling. Then preprocessing and wave with subclasses, saving model and validation. See the image distribution by class. I also subfolders of classification of the cervical cancer diseases. Okay, then we, we did an epoch for the getting an accuracy. Earlier we got loss of 1.9884, accuracy of 0.41, and validate loss of 1.8354. Validate accuracy is 0.5275. Then finally we got loss of 0.2454, accuracy of 0.9964, validate loss of 0.2395, and validate accuracy is 0.9962. See the validate accuracy and the training and validation loss with respect to epochs, and this is training and validation accuracy with respect to epochs. Then see the test accuracy of 0.9962 and confusion matrix. Then you create cam image. In this original image is like this, create cam heat map is this, and heat map overlay is this. Now coming to our, this is back end. So front end I will show you front end. In this front end I did an application. So first we have to go to home page. Okay, our home page is like this. In this we have to do which I have shown in earlier. So now we have to upload. We can able to classify the cervical cancer. Okay, click here. So cervical cancer detection using histopathology images. Please upload the clear image. So I have to upload the clear image of the data set. So then we will get the different type of classes. See the images. First I will select this one. Okay. Now predict. It will predict the class of the cervical cancer disease. Okay. See the disease. I got the name of the disease in the class of the cervical cancer. Health checkup and home prediction comfort. High squamous intraepithelial lesion. Disease detail. Disease name and cause. For the cause for this is persistent infection with high risk human papillomavirus HPV strains leading to several diaplasis or precancerous changes in cervical cells. Treatment for this: colposcopy, guided by POSI, followed by exercisional procedure like LEAP or cold knife cognition, HPV vaccination, and regular PAP HPV screening. Second one, we'll see another one. So choose the file, choose anyone. Okay, I will choose this one. Then predict this class of this name. See the name of the class. Squamous cell carcinoma. This is the disease name. Cause for this invasive cervical cancer arising from long-term iterated high-grade lesions, primarily driven by persistent high-risk HPV infection. Treatment for this is combination of surgery, radiation therapy, and chemotherapy, depending on the stage. Early detection is critical for successful outcomes. See the another one. Okay, we will upload this. See this name. Negative for intraepithelial malignancy. Disease details. Disease name. This is name. This is cause. This is treatment. For cause is normal cervical cells with no evidence of precession or cancerous changes indicates healthy cervical epithelium. Treatment for this is runtime cervical cancer screening as per guidelines. Maintain good reproductive and sexual health practices. And we'll see another one and we'll finish it proper. Okay. Okay, we'll predict for this one also. Then we will finish it up. High sequential intraepithelial lesions, disease detail and cause and treatment for this. Which is already I have told you. Okay. If you have any doubts regarding this project, you can contact us on the website, or you can contact through WhatsApp number, which number we have given in the our website and below the YouTube video. Thank you for watching my video.